Hey everybody. So we're going to do the final exam study guide review, and we're going to try to get through some quick points about everything. I'm going to try to make this pretty quick because I'm a little under the weather right now. So we'll see how it goes. Let's just jump right into it. So key skills, starting from the top down. So the first thing is defining a function. So defining a function is like this, where you say def, which is short for define here, and this is the name of your function. And if you had any parameters in your function, you'd pass them in like this. You'd say parameter 1. Ugh, goodness. Sorry, guys. Parameter 2, and so on and so forth. And then you would just use those in the function. Now, like for example, I could use string here, and I could say string, and then I could just not define this, and then I could just use that when I call the function. So now, when I call the function, I'm passing that into it. Now, a helpful thing to know about functions in Python is that when you're actually defining the functions, well, two helpful things. First of all, you don't have to return anything depending on what your function is doing. So if you don't want the function to return anything, like if it's supposed to return none, you don't have to say return none. You can just not put a return statement, and Python will interpret that as none. So it kind of saves you some code space if you are that OCD about it. Personally, I think if you type return none, it makes you look kind of like not as good. Sorry. Anyway, just a quick tip there. But the other thing I was going to say was, a helpful thing about functions in Python is Python doesn't actually execute any of this code until you actually call the function. And I know that sounds obvious because that's what calling the function does, but what I mean is, like, usually when you write code in Python, like if I say x is equal to like 5.0 and then I say x dot split, like that doesn't work because it's not a string, and I'm trying to use a string method. So Python would give me an error here. However, if those same two lines were in the function above, Python would not encounter that error. It would not throw me an error when I start the script until it runs this block of code from line 10 all the way down to line 17. In this case, I guess line 19, because it would be two more lines. But anyway, that's one helpful thing about functions in Python. So you can define as many functions as you want, but as long as you never actually call them, they never execute. So it doesn't matter if you have any errors, which could actually be a problem because you might not catch the errors until like 30 if statements later when your function finally runs, which could be a problem. So it's good to like make sure you test your functions and stuff every time you add a function. Anyway, calling a function and appropriately use the return value. So if you're returning anything, for example, if I return string here and I want to assign that to my string, I could say string, I could say like returned string is equal to this function. So now what's going to happen is, because I returned something, now I can set this equal to whatever that return value is of my function. So when you define a function and you have something that it returns in the function, what you're actually doing when you assign a variable to a function call, what you're actually doing is you're assigning the variable to whatever this is. And this may be a little bit more complicated, so you don't have to remember this, but you can return multiple things. You could say string and then string 2, and then I could say return string 1 is equal to that, and then return string 2 is equal to that. That's how you would unpack that, is how they call that. But you don't have to remember that. It's probably not going to be on the exam, but I just wanted to share that as a helpful tip for you. So let's keep going here. So for loops and while loops, I've already talked about this like 50 times, but just as a quick recap here, for loops are best when you're trying to iterate through a specific thing, and while loops are better if you're just waiting for a condition to happen. So, and you can use a while loop like a for loop, but just in general, I guess the main difference between them is like a while loop would be good if, for example, you're waiting for a condition to happen. Like, for example, in the pig game, the user can stop rolling at any time unless they roll a 1, in which case it auto stops them. But if they don't roll a 1, and let's say they roll 50 times and somehow never get a 1, they could at any point during that 50 times just say, hey, I don't want to roll anymore. And that's a good example of when you use a while loop, because then it's like you're not iterating through a list of rolls or whatever. It's just like whenever the user wants to stop. Or just like user input in general is just a really good example of when to use a while loop. So, sorry. So a for loop, though, is better if you're iterating through a specific list of things. Like, for example, a string. A string has a list of characters. I mean, that's actually what it is, because Python is actually coded in the C language, and C treats strings as a list, actually. Not exactly in the way you might think, but it's like a list, basically. That's how C treats strings, and that carries over into Python too, except Python is just a little bit fancier and a little more user friendly, but under the hood it's treating it like a list, kind of. So you could think of lists and strings as kind of the same thing, just not, it doesn't look exactly the same, but it's kind of the same under the hood. So anyway, so a for loop is good when you have to iterate through something that is iterable, as we would call it. For example, a string and a list are iterable. You can iterate through each character or index of the thing. In this case, I'm traversing by element, so I said for each character in the string, I want to check something about it. Now, in this case, I actually defined my element variable as character, but I can make this anything I want. It'll throw errors at me because it's listed that way everywhere else, but just pretend that this changes it everywhere. But I could say like for S in string, or I could say for letter in string, which it may not be a letter, so I try to just use character in that case. But this word doesn't really matter. I mean, all that matters is that you're consistent with its usage. Like here, I'm saying if it's a digit, then print it's a digit. If not, it must be a letter. You could have like, symbols and stuff in here, so that would be one way to kind of make the code sort of buggy in that it would say it's not a digit, which technically I guess is accurate because a dot isn't a digit. So I mean, I guess it still technically works. But anyway, this is just simplistic code to get my point across. But that's my point. So traversing by index. Traversing by index would be if you did instead for index or I, which is what we usually use just to save writing space. But I want to write it out so you can see it. But for index in range, length of string. And then you would put your colon and then the same. I could just copy and paste the same code. Now this code would actually do the exact same thing, except everywhere you see character, which luckily only appears 3 times in the code here, you would just replace that with string, and then you would put your whoops, I'm sorry, I keep doing the wrong thing. Then you would put your index. In this case, you could use I. Like I said, this word doesn't actually matter. All that matters is you know what it means. And to know what it means, this represents your index. That's why I wrote it out, so it's a little more clear as to what it's doing. But that's basically it. And then, if I was being like really serious, I would replace these two. But, you get the point. But this is traversing by index. So basically, what this is going to do is it's not going to look through each letter of the string by each character, but rather what it's going to do is it's going to run this line of code each time. This string index. And from a for loop, excuse me. Okay, sorry. For a for loop, what it's going to do is it's going to add 1. So this value, even the character thing here, but it's especially true with the index. This value is going to start at 0, and it's going to keep going up each time until it reaches the range. Now, we passed in the length of the string here, and I think the length is 7 characters long. So this is saying for I in range 7. And remember, range stops when it gets to the number, so it's going to go 0 through 6. But if you do the math, that's still 7 times, so it works out. But basically, this is going to be 0, and then on the next iteration after it does all this, it's going to be 1, and then the next iteration it's going to be 2, and then 3, and then 4, and then 5, and 6, and 7. Oh, what a mess. What a mess I just made. There we go. But anyway, so that's basically what it's doing. And then you could just imagine that this says string index everywhere you see character here. I'm just a little too lazy to copy it out right now. But anyway, so that's how you traverse by index, and you can do the same exact thing with lists. and strings. So it's the exact same thing. That's why I'm treating them kind of the same as well, because they have very similar properties to them in some ways. So we're going to get rid of this mess because I don't want to confuse the code even more. So, yeah. Okay. So building a string, let's see, we traverse by index, for loop with an element, okay. Building a string just means you're adding something or subtracting something, or you're modifying the string as you go through it, and not necessarily modifying the string that you're iterating through, but maybe you're building a new string. So, for example, and I won't put this in a function, I'll just say, like, for I in range 5, container string, I think I might have misspelled that. The brain frog is getting to me, guys. Okay. So we could say, sorry, we could say container string plus equals x. So now what we're going to do is it's going to make this x, and then it's going to make this xx, and then xxx, and then xxxxx, and then xxx, xx, or something like that. So it's going to, by the end of it, it's going to print 5 x's. But if we print it in the or in the for loop, then it's actually going to print all of them as it goes through. Whereas, like, if we print another line here, and then we print the container string outside of the for loop, then what's going to happen is it's going to print all of them. Of course, oh, yeah, we didn't actually add that on. But anyway, building a string, you're adding something to the string each time. So, yeah. So anyway, why is it not? Let's break out debugging. This is a good example to show you debugging. So if we debug it here, we're going to say, oh, yeah, duh. I'm sorry, guys. It's because I define the empty string in my for loop. That is a great example of why debugging is important. Because watch what happens. I would have gotten here, it would have went to X, and then it would have executed that line. And it keeps, I mean, I changed where it was, but it keeps showing that it's defining it as an empty string. So now, if I rerun it again, we can see this is where it printed just after the for loop, so after the final iteration, and this is where it printed it on each time. Yeah, I'm sorry, guys. I'm sick. It's been a day. Okay. Anyway, so that's how you build a string. Same thing with a list or a dictionary. It's just you're just adding something to it. Now, with a list, though, you have to be a little careful because it matters where you put the item in the list. Like maybe, I guess depending on how specific you want to be, maybe you don't want to add something to your list like right at the beginning or right at the end. Maybe you want to put it in some kind of sorted order or something. Or with dictionaries, it's, a little bit different syntax as well. But basically, that general idea of adding something to an existing string or empty string or whatever, that's how you would build a string or a list or a dictionary or whatever. You would just add something to something or remove something from something. But just as a general example, though, you don't want to change the thing that you're iterating through. So notice I did for I in range 5, and I didn't say for I in range length string or whatever, because I don't want to modify the thing I'm iterating through. That can cause problems. Okay, so accumulating a sum. Same thing we just did. But instead of adding to a string, you're adding to like an integer or a floating point. You're adding like a score. Like in the pig game where you had to add up all the sum of their rolls. Same thing. You just loop through and you keep adding to something until finally you're done or whatever, and then you return that value. Or until some kind of condition is met or something. But that's how you accumulate a sum. So, hang on, guys. Okay, sorry. All right. Create and evaluate arithmetic, Boolean, and string expressions and combinations. So this is just saying, like, where we said if character is a digit and one or two or three. So what this would evaluate to is, so what this would evaluate to is it's going to say, is the character a digit? And the first letter of the character, if you look down here, first letter is a W, so it's not a digit. So this part is false right here. And then this is true. And I know you might be thinking like, well, I mean, yeah, like it's not a 1, so that this should be false too, right? But actually, we didn't say and character, if I can spell, equals 1. We didn't say that. We just said and 1. And any string that's not empty will evaluate the true. So this is if false and true, which can't be true, or true or true. So or means, okay, well, that stuff doesn't matter, but maybe this does. So when it gets to this or statement, it's going to say, okay, well, 2 is true, so we'll just go ahead and execute it. And this would actually break my code if I run it now. And see, now it's going to say everything is a digit because it has these or statements. But notice if I remove this, it shouldn't do the same thing. So, see, now it's acting like normal. And that's because this is never, like, it's either always going to be false and true or true and true. But it's never, and false and true always evaluates to false anyway. So this works perfectly fine, although it's really dumb looking code and doesn't mean anything. But it technically doesn't break the code. But anyway, that's how you evaluate arithmetic statements. Now, I already talked about this in my midterm video, so feel free to go back and watch that. But I would encourage you to watch the section where I talked about what variables evaluate to what. Now, I didn't talk about lists, I don't think. An empty list will evaluate to false, and a list that has literally anything in it will evaluate to true. And I think the same is true for a dictionary as well. So that's basically all you need to know about that. That's pretty much what they're saying here. Sorry, guys. Okay, create conditional statements. So if, else, and elif, and else. So if just means if this is true. Now, notice I didn't have to say if character is digit equals true, because is digit will return a true or false. Notice I don't have to say if it's true or not. In fact, if you actually look here, I can actually say, it says replace the Boolean expression with, because even PyCharm, which I'm using right now, knows that that's silly, because I don't have to say equals true or equals false, because just saying if character is digit is enough for PyCharm to understand that means if true or false. Because this whole like block of code right here, not the if part, but this particular part right here is going to evaluate to true or false. It doesn't matter what the character actually is. I mean, it does for this part, but the actual part here is basically equal to true or false. So you're basically saying if true, then do this stuff, and if false, then okay, move on to the next condition. Now I could say like if the character is a symbol, so like I could add a dot in there. And so what I would do then is I would say elif character equals a dot, then print f strings are awesome, by the way. Character is a dot, right? So now what's going to happen is, even though it's not a digit, so it could execute this code, Python is going to first go down to this line, and it's going to say, well, okay, this isn't true, but maybe this is. So it's going to look at this, and it's going to say, is it true? Sure, why not? If it's a dot, so let me go ahead and put a dot in there so you can see what I mean. Actually, let's put it between the characters. So it kind of goes in order, sort of. I mean, it will still be kind of backwards, but you know what I mean. So now, if we debug our code, which again, debugging is extremely important. I want you guys to really know how to debug your code before you leave this class. It is extremely important to know. So I'll show you in VS Code too by the end of this video. I'll try to make it kind of quick though. But anyway, you put your breakpoint next to the line, and then you click, instead of to run your code, you click to debug your code, and then you do that, and then it's basically gonna like stop on the first line that you put your code in, or put your breakpoints in. So it tells us what the string variable is. See, I don't even have to go down here to see it. It tells us right there. Of course, in VS Code, it'll be like somewhere over here, I think, but it'll be kind of a window like this, basically. So now I'm going to go ahead and execute this first line. You're going to notice that there's going to be another thing down here that's going to say character equals, and it's going to say W when I execute that, and there it is, character. It also tells us it's a string, but we can also tell that by the quotes there, but even if we didn't understand that, we could see it says it's a string. So, excuse me. So it's really important to know what the values of your variables are and what type of variables are they. And that'll save you like hours of time trying to code, I swear to God. It's very important to know. So, okay, W is not a digit, so it's going to go ahead and say, okay, is it a dot? Nope, it's not a dot. Okay, then print it's not a digit. Okay. So we're going to skip ahead here because it's going to do the same thing for OR and D. But notice it does try to at least go down and check these conditions before it just skips on, because it has to know. Like, it can't know without trying it, so it's got to try, It's like your favorite food. You can't really know until you try it. So, is it a digit? Okay. Is the dot a digit? No. Okay. Is it a dot? Yes, actually. Okay, it's a dot, right? And now you guys can't see this, but if I click over to console, you can see it has been printing stuff. So, of course, it said WRD is not a digit, and the dot is a dot. And so now if I go here, okay, is 1 a digit? Yes, print. Okay, is 2 a digit? Yes, print. Is 3 a digit? Yes, print. And then it's done. Right, and that's debugging, just to knock that bird out, the 2 birds with 1 stone there. And that's how if statements work. So I could make this another if statement, but ideally you don't want to, like, basically whenever you want to use an if versus an elif, because you'll notice Python won't yell at me if I do this, but the idea of when to use an if versus an elif, first of all, you have to use at least one if before you can use an else if statement. But an elif statement only executes if the if is like on the same indentation. Excuse me. If the if is not true. So if it's not a digit, it's going to skip down to here and it's going to try to execute this code. And then it's going to get to the else statement if it's not a dot either. So that's how you would like do that basically. That's how if statements work. Okay. We know about print. Print's pretty obvious. I think we should know print by now. I went over it in my midterm review, so we're going to skip that for time. I also went over input in the midterm review, so we're going to skip that as well. We didn't go over files. So, of course, I don't really have a whole lot of time. I don't want to spend 3 hours on this, but basically, you would just open a file. If you had a text file in your directory and you want to open a file, you would just say, you would use the open function. So I'll just put it up here, even though it's not going to make sense because there's not a text file. But you would just say like open and then my text file dot text. And then right here you would say I want to open it as writing. So I don't care what's in it. I'm going to write over it. I don't care what's in it. Or here, if you just want to read the data and like do something with that data, like down here, for example, I could read a text file and get a line from it and say for each line, check if it's a string or if it's like a digit or whatever. And if I want to if I don't really care about reading the file, but I just want to write something to the end of it, like if you were using this for like a log or something, then append would be really good, and that's what the A is for. So that's how you would do that, basically. And you could do the same thing with CSV files as well, because CSV files are really just like text files in a way, but they just have commas separating each item, basically. Sorry, guys. Okay. Oh, and traverse by line, I didn't go over that part. Let me go over that real quick. So if you already have a file that's open, and you say like file is equal to that, then you could say like for character in, actually, you could say like for a line in file. Now, like I said, this word here doesn't, like this word right here, doesn't really matter what you call it, but I would really encourage you to use something that's descriptive. I know people will say like for S and string and stuff because it saves time, but trust me, I don't care about saving, like typing S versus line is literally like 3 other letters of time. It's not really saving you that much time, and if anything, it actually is saving you a lot more time to write line, because when you go back to your code like a year from now, you're not going to know what the heck you meant by for S and string or whatever. Like, maybe you will, but, good luck, I guess, which is, rough. But anyway, so you can imagine if I had a text file here and it had like 3 lines in it, then this is going to represent the line, and it's going to have the /n character in it for each new line as well. Especially if it's a CSV, it's going to have that plus a bunch of commas in there too. So, it is what it is. But anyway, so that's how you work with text files and CSV files. Also, just to remember, if you want to split a CSV file, so you could say file is equal to open my CSV file R, then you could say file dot strip would get rid of the new lines. So you could do strip here. But if you were doing like for line in file, then you would want to do line.split, and then you want to split it by comma. And then you'd want to say split line is equal to that. Now, I've seen people do line equals line.split. this technically works. I'm not saying it doesn't work, and if it works for you, then just, keep on at it, I guess. I don't really like this syntax because I think it's a little confusing because you have line right here, which is actually a completely different line from what line would be here. Because this is a string and this would be a list. It'd be a list of strings. So these are two completely different variable types. Sorry. And I just I don't like seeing that. I feel like it just looks like bad code, but I don't know, who am I to say, I don't know, just a personal preference thing. So I always try to say like split line is equal to that. And then if I just want to iterate through that, I can say like for word and split line or something or whatever. So then it's like I'm actually iterating through the list and not just the string of it. But anyway. Okay, let's get rid of this nonsense before it clogs up my function here. So let's move on here. So dictionaries, to add a key value pair, retrieve a value, traverse by key in sorted order. So if we have a dictionary here, and let's just call it dev dictionary stuff, and let's pass in a dictionary here. So let's go ahead and say dictionaries, example dict object is equal to stuff. I should make this a string. I don't know what I'm thinking. 1, and then stuff 2 is equal to 2. I would encourage you to use better variable names than I did. But, it is what it is. So now this is our dictionary. So now we're going to pass that into dictionary stuff. There we go. So now we could say if I want to retrieve that, I could say return dictionary stuff. What this is going to do is this is going to give me the this is going to give me 2 because this represents the value. So this is the dictionary and this is the key, and when you pass in the key to these brackets, what this whole thing evaluates to is the value of whatever the dictionary with that key is. Now, if I want to get the actual key itself, that's a little bit different because then I would have to kind of like either say dictionary.keys or something or whatever. But typically when you iterate through a dictionary, this isn't really iterating, but when you're going through a dictionary, you already kind of know what the keys are. But let's say I didn't know that stuff was a key. So maybe first of all, I just want to print dictionary.keys. And so now if I have to put a bracket there because that's a function. And I don't have to put a print statement here because it's going to print inside of that function. So now if I run this, it's going to give me all the word things here. But, I'm getting some kind of syntax error. Hold on, maybe that fixed it? I think it's just weird about the spacing or something. Oh, you know what? I didn't put a comma. That's silly. I'm telling you guys, the brain fog is getting to me. Okay, so then it gives me back this object here, which isn't super clean, but it tells me what I need to know. And it says that there's a key here of stuff, and there's a key of stuff too. Now, we already know this, but let's say we have some crazy complex script here, and we don't know exactly what's in our dictionary, which would be another good example of when to use debugging. But anyway, with this print statement, we can at least figure it out in the console if we need to. So, excuse me. So, anyway, so this is our keys. If I want to get the values, I could just say dot values, and then it'll do the same thing, but it'll print me 1 and 2 there. And then if I want to get all the keys and values, then I want to print items, right? That'll give me both. So this will give me a tuple. This is what this is called. The little parentheses pairs here. This is a tuple. This is a list of tuples to be specific. So this is our first key, and this is our first value of that key. And this is our second key, and this is the first value of the second key. This could be a list. This could be whatever. You don't have to use a string. You could use whatever, but just as an example. Sorry, guys. Okay, so that's how you would get the keys, values, and items if you want all of them. And if you want to iterate through these, then you'd basically just do the same kind of concept, because remember, this is a list. So you could say, for example, for key in dictionary dot keys, I want to print the key, okay? And that's going to print it one after another, which is a little bit cleaner to read, but can be a little confusing if you don't know. And I'm going to actually just get rid of this function call for now, because it's kind of, clogging up our console here with stuff we don't need. But anyways, this prints out the keys, and then the same exact thing, I can say, instead of that, I could say for value in dictionary dot values, I want to print the value, right? So then you could print the values 1 and 2. Now, let's say I want to print both. Well, I can't just say items here and be done with it, because Python will give me an error saying that I don't have enough data to unpack here. Of course, Python is smart enough to know this, but ideally what you would want to do, though, really, is you'd want to actually say for key and value, and then you just want to print those separately. That would be the better way to do it. Kind of like enumerating, basically. So it's going to print it a little strange here, because, I put a comma, so it's just going to add a space between them. You may want to do like an F string and put like a semicolon. In this case, I'll just put like this, and then I'll space it out, so it makes it a little bit easier. It's still going to add the space in between all of it, but at least it looks a little more clear as to where the value starts and ends and all that. But anyway, that's how you traverse things. And so if you notice, I'm actually traversing by both the keys and the value, but I'm not traversing like two things at once. I'm really just getting both things as I go. So it's really just traversing one thing at a time, but it's just looking at both values each time. But again, if I say for key in dictionary.keys, then I can print the key as well if I had a colon and not be silly. And that's how you do that. Okay, moving on. So and sorted. Okay, same thing basically, but you would just add the sorted function around what you're trying to do, and then it's the same thing. In this case, I think it's still going to be exactly the same. It's still going to print stuff and stuff too, but let's say I, for example, make this like example, then it would actually print example first, I'm pretty sure. Yeah, because it's sorting it by alphabetical. And that's just basically, it's as easy as that. You just wrap it in the sorted function. Now, you could do dot sort, but the problem with dot sort is that dot sort is not good for for loops in this way, because this is actually going to be none. So if I show you this, if I do dot sort here, this is actually going to evaluate to none, so it's not going to give me what I need. Of course, I can't do dot sort because I think it's also a list method as well. But just as a reminder, and we'll go over that in a second. But let's move on here. So classes. Define your own types, methods, instance variables. Yeah, I can't really show you my homework because it's still early enough that I might get in trouble if I show you my homework. I did finish homework 10 in the discussion, which has class examples that I could use, but I don't want to show you that in here because I think I'll get in trouble if I do. So let's just say class example, and we're going to say def init self, and we're not giving anything when you pass through anything. Now what we're going to do is, instead of making these functions, we're actually going to make them methods. And the difference between a function and a method is that a function actually doesn't let's give it something. Let's give it a string. That makes it a little clearer as to what we're doing. So let's say string. Oh, whoops, I'm silly. We don't want to pass in just the actual string, like a literal. We just want to pass in a string variable. And then we're going to specify that it should be a string when people use our class here. So we're going to say string, and then we're going to say self.string is equal to string. I'll go over this in a second, but I want to talk about the method thing. So basically, where are we getting errors? What am I doing wrong? Unresolved reference. Class example string. Oh yeah, sorry. My bad. Sorry, guys. I'm being silly. Okay, and now why is this giving us an error? Unresolved reference dictionary stuff. Dictionary stuff. Oh yeah, I didn't properly do that. And now I just need to replace this with self.string. This is not a valid identifier. Oh my god, okay. String. Except for here. Okay. Alright. Okay, so I just need to close this out here. So, yeah. Anyway, def doing stuff. Why is it yelling at me? It's like I'm missing something. For character, it's self.string. I think I just need to say example string. Anyway, basically, I can't. My brain is too fogged right now. It's hard enough to sit up, let alone do this. But anyway, the point that I'm making is you would want to. Let's just get rid of this. Let's just not make this in the class. I don't really care anymore. So anyway, yeah. So basically, what you'd want to do is you would want to create a class. Now notice this is outside of the class because, oh yeah, sorry, you don't have to put a parentheses when you create a class. So this is me defining the class. This is the init method. So this is I'm initializing the class with this information. So this string, this class starts with a string. So whenever I define the class, whenever I call that class and initialize the class, I have to then utilize this string variable when I'm defining it. So I could say, for example, this is where I was getting it confused. I could say, for example, stuff is equal to, which is a terrible variable name, but you'll hear me out here in a second. Stuff is equal to example string to use, right? And so now this is a perfectly valid class. This is an instance of the class that I just created up there. Now the only thing we actually have in the class is just the init method, so we're not actually doing anything with it. But like I was saying, if we wanted to, we could then say def doing stuff with class string is equal to our string here. And then we could just kind of copy this code at that point. Whoops. Wrong button. All right. And then, yeah. And we just want to create this. And, yeah, basically, oh, whoops, sorry. And then we just want to say self.string. And then at that point, we would be calling that function here so that we can do that stuff. So now this code will do the same thing. In fact, remember, I'm not calling the doing stuff function, and I'm not going to call the dictionary function either. So let's go ahead and clear that out. So now let's say we call in the same exact function here, and we say word123, word.123. So now, if I were to call this function here, initialize the class and do that, then basically what's going to happen is it's going to print all these things exactly the same way it did before, right? Now in this case, it doesn't actually print anything because we are never actually printing or calling those functions directly. So what we'll actually, because all we really did just now was we initialized the class and we told it what the string is. But now to actually use that, then we just need to say print stuff, because it's the name of our initialized version of that class, print stuff dot doing stuff with the class string, right? Now we don't have to pass in what the string is because we already passed that in when we initialized the function, or initialized the class, I mean. So now, if we print that stuff out, then it will go ahead. Of course, it's going to print none. I guess I should have not put the print statement there because whoops. But anyway, now it's going to actually execute that method there. And so it's kind of the same thing as when you like call a function. Like it's the same exact thing in this case as me saying doing stuff with word 123, right? It's going to print the exact same thing twice. Kind of hard to see, but it did. So this is where it ends, and this is where the other one begins. Sorry. So, but the difference is now we have a class, and we can get like other attributes from it. We could say it has a string, maybe it has an integer, maybe it has like a bunch of stuff, and we could go ahead and define all those. Now, the point of this self.string equals string thing is the string, as you can see with the color highlighting, this string is actually the parameter that we passed in. What we're basically telling Python in this line right here is that when I call whatever the name of the variable is, dot string, then it should print this. It should give me that value, right? Sorry. So if I go in here and I say print stuff.string, what it's going to do is it's going to print me word.123 right underneath this, and then it's going to print all this crap too. So now, if I go ahead and run that code, you can see it prints out word.123. And that's because what we're saying is, just pretend that this is stuff here when I say self, because I'm referencing whatever my instance of my variable is. In this case, it's stuff is my class variable instance. But it's basically saying stuff.string is going to be equal to whatever we passed in when we initialized the function, hence the init method. That's the whole point of it. Now, the def repr method, so whoops, if I can spell, the def repr method is sorry, basically a function that runs when you print the actual thing itself. So if I go here and I print stuff, it's not going to actually print me anything, even though I passed in that string there. If I print stuff, it's not going to print me anything. It's going to print word.123 and then none and then whatever. And oh, I didn't. Whoops, sorry. I did this, but I didn't actually do anything. So now it's going to print me return none. Okay, you know what? Let's just do this, I guess. So now it printed a new line because that's what Python does when you do an empty print statement. But basically, this is evaluating to an empty print statement because this is basically the same thing as me saying print this. So return is just telling it what do I print when I print the class. So if you just have me print the class variable, what do I print? That's what the repr method does. So I could say, for example, this is a class that has some string methods that affect whatever string you pass into it when initializing the class. I don't know if that'll work, but yeah, there you go. It kind of got confused because I didn't add a space after that, but yeah. So anyway, that's what that does. So return, basically when you say return, what you're doing is this is the value of what it's going to print whenever you print the class. And you don't have to make this a string specifically. I mean, it has to be a string, but you don't have to make this like just a string. You could use like an f string or string concatenation to say like, this class uses, and then I could say self.string to do some string methods on, right? That's the beauty of f strings. You just put a little f here, and then you can put these brackets and put in whatever your variables are, and it's just great, and it's really easy to read. So now it's going to say, this class uses word.123 to do some string methods on, right? That's what the repr method does. Super simple, right? You just return, and you can put this anywhere in the code. It doesn't have to be at the end. It doesn't have to be at the beginning. It can be anywhere. Except, I would recommend that you put it at least under the init method, because if you're going to reference any of these things, then yeah, you need it to be under that. I think it at least has to be under the init method. You might want to test that, but just in my experience, I think it's better to at least be under this, like somewhere over here or below. I always put it at the end of my classes, just so that it's like the last thing that you see when you see your class, but just my personal preference personally. But it doesn't technically matter. I could have put it like right here, or, you know, if I had like 10 other functions, I could put it somewhere in between all of them. It doesn't really matter. Anyway, okay. So moving on for the sake of time, sorry I went so long on that. Let's see. Instance variables, creating an object, okay, accessing the data and methods, yep. So I already told you, like, to access the method, you just do stuff dot string here will get you the attribute, because remember we named the attribute string. And to access the methods, you say stuff dot whatever the name of your function is in there, your method, and that will get you the method. And stuff here represents the name of the variable that represents the class object. So stuff.string will print me word.123, because that's what we passed in as a string. And then this will print me the repr method of what we returned out of that. And this will give me the function that I wrote, the method that I wrote for that. Okay, moving on for the sake of time. Mutable versus immutable. In Python, that really just means things that you can traverse and modify without it having to create a new object in memory, which may not be easy for you guys to understand if you've never coded in any other language, or maybe not used a more low-level language like C or something. But basically, every variable that you create has some kind of memory address in your RAM. And so an immutable object, like a string, for example, if you modify that string, what Python actually does is it just kind of like overwrites whatever the original string was, and then reassigns the string to a new value. Instead of just like modifying whatever the value of the string is, it's actually going to basically overwrite the whole thing all over again, and it might assign that to a new value in memory, I think. I'm pretty sure that's how that works. There's also some other things, like there's some other tricky things about mutable versus immutable, like if you print the value, it may not print the modified value and things like that. But yeah. Okay. Yep, this is just stuff about the test. Okay. Know everything about the midterm guide. I have a video on this. Just feel free to go back and watch it. The built-in types. I already went over string, integers, floats, and booleans in my midterm guide. The dictionary, I just showed you how to make a dictionary. And the list is really simple. It's just example list equals like 1, 2, 3, right? And I could put strings in here. I could make this a string if I wanted to. It can be all kinds of different things. I can make a dictionary object. I can put a tuple in there. List can kind of hold anything pretty much. It's just like a bucket. It's like a container. It just contains a bunch of stuff. Excuse me. Sorry, guys. You can also define a list as an empty list. So you could say like example list equals, but then just make it an empty list. And then you could add stuff in the list using like a for loop or something if you wanted to. This is especially helpful if you already have like a list of, like, let's say you have a list of words, for example, and you wanted to go through that list of words and say, every time I find a word that starts with J, I want to add that to my empty list, right? And that would be a good example of when to use an empty list, is like just as a container to hold all the things that you want it to hold while you're going through another list or another dictionary or whatever. And that's a good example. So anyway, there will be an expression evaluation section. Okay, we kind of already talked about expression evaluations, like the and or and not and all that stuff. Know how the and operator works. It's basically just saying, like, if I have a string here, example string is equal to word.123 here, then I could say if w in example string, then print true. And what it will do is it'll still run all this other code, but what it'll do now is at the very top of this, it's actually going to say true. Of course, I should really just print it as a string, because print prints the value of it, so, you know, it's better. But yeah, so it'll print true. So that's what in means. It just means, is this particular object in whatever we're iterating through? And so is W in the string? Yes, it is. This could be a list. It could be a string. It could be dictionaries even. But as long as it's in whatever thing you're iterating through, in this case, we're not really iterating through anything because it's not like a for loop or whatever. But if it's in whatever iterable item or object that you have, it'll print true or false, basically, is what this code does. But I don't have to say print true. I could do something else with it. I could say then, w.upper or something, right? It doesn't matter. But the point is, I could do something with that data. And that's the benefit of that. Okay. All right. I already went over this in my midterm exam, so we're going to skip this for the sake of time for you guys. I don't want this video to be like 3 hours long. Evaluate Boolean expressions. We did kind of already talk about this. We didn't go over the greater than or equal to or whatever operators, but it's pretty straightforward. This just means it's less than. This means it's greater than. And the position of how you type things matters. So I could say like, if x is equal to 2 and y is equal to 3, then x is greater than 2. And if I printed this, it would print true, right? So, of course, I can add spaces here. I don't have to be a total barbarian here and not use spaces in my code. So then I could say, whatever. Of course, actually, this is false because I'm an idiot and 2 isn't greater than 2. I don't know what I was thinking. I was trying to say x is greater than y, in which case it still would have been false. I'm just super sick right now. But yeah, but if I change this and I move this over, then it will say true, I'm pretty sure. Yeah. See, I'm not completely out of my mind. But I can't say, but if I say, is it greater than or equal to or less than or equal to, then it will say false. Excuse me. And you can kind of see how it changed, but I did add the equals. It's just PyCharm automatically formats that for me to look a little better, but anyway. So now if I run this, it'll still say, whatever, but in this case, because it is actually greater than or equal to, it's going to print true because it is greater than, but it's not equal to. But because it's one or the other, it's going to be true. If even one of those are true, it's going to print true. So if I make this 2, it's still going to print true. And if I make this 3, it's still going to print true. But if I make this 1 or anything less than 2, then it will print false, right? So that's the whole point of those operators. Oh, and you might have not seen this one as much, but the exclamation point equals to means not equal to. So if I print x is not equal to y, it's going to print me true because it's 2 and that's 3 and they don't equal each other. Now, one thing I really want you guys to pay attention to is just because the values are technically the same doesn't mean that they still will print true or false correctly because the type of variable they are have to be the same. For example, this is a 2 as an integer, and this is a 2 as a string, and they're not technically the same. In fact, this will print, like, PyCharm is smart enough to know that it's technically the same. But if you're actually debugging your code and you're like, if you have a function, it's not technically the same. Python doesn't understand that 2 is not the same as the string 2. So this isn't a good example because PyCharm is smart enough to know this when you're doing operators, so this probably isn't the best example to use. But say, for example, that I had some kind of like string thing here, like kind of like how I'm going through the string and checking if it's a digit or not. I could say if, like, let's say, for example, if character equals 1 or character... Why is this yelling at me? Oh, the comma. Okay, sorry. Or character equals 2, or character equals 3, which we know is the only numbers we have in our function, then it shouldn't print correctly, right? So in this case, it does because I think this is like a Python update or a PyCharm update. So I think we are getting lucky here, but the point is that, like, typically when you're debugging, Python doesn't treat these the same. I guess it does now. I mean, maybe I could be wrong now. I don't know. I guess it would be a PyCharm thing because that's the only thing I've updated. I haven't used a different version of Python here, but anyway, I guess that disproves what I was gonna say. Which I'm happy that I'm giving you guys the right information and not misleading you. So it's good that I always test things for you guys. But you still need to be careful of your types of your variables because you could still run into problems. I guess maybe not anymore. I don't know, but just best rule of thumb. Maybe you're on an older version of Python or something. It could still matter somewhere. Maybe if anyone else has any information to share about this, that'd be great. Because I'm still a little confused on it, because every time I did that in the past, it never worked. But anyway, okay. So moving on here. So we already talked about all the operators. Remember that if you just use one equal, you are assigning that to that, right? But if you use two equals, you're saying, does it equal that? So stuff equals equals. It's like, does stuff equal this? Well, of course it's not, because it's just like a weird case scenario. But if you were using some kind of other function here, like for example, where we say if the character equals a dot, then we want to do this. But we didn't say if the character equals dot. We want to say equals dot. That's how we say, is it equal to? This evaluates to true or false. So is this true? Then yes. If not, then skip and do whatever, or do this, I guess, depending on what it is. So anyway, okay, moving on here. So the length function, I already talked about the length function. It's pretty obvious. You basically just write, like, for example, example string is equal to word. And then if I print the length of that example string, should print me 4. Now, I want you to pay close attention to this, because it always returns an integer. Length will always return an integer. Or, if, for example, this is an empty string, then in that case, length will still return an integer, but it'll be 0. And the significance of that is that if this is 0, this is going to evaluate to false. This length, this block of code here evaluates to false. So if you're ever using some kind of if statement and you have this in your code, it's gonna evaluate false. It's not gonna execute that if statement. So just keep that in mind. Be careful when you're using this length function here, because 0 will always evaluate to false as an integer. Same thing goes with this empty string. Of course, if you were checking to see if there were characters in the string, you could just say if example string, because that would just automatically evaluate to true or false. You don't even have to do this. You could just say that. You don't have to do if length example string, then do whatever. If you just want to check if the string is empty, you could just say if not example string. And then that's the equivalent of this line of code here is the equivalent of telling Python, if this string is empty, then do all this stuff. Of course, you have to indent it, but you know what I mean. Okay, moving on. So let's go ahead and add something back into that string so I can do stuff with it. Let's just say words. Okay, moving on. The split function will split by whatever delimiter that you use. So, for example, if I say words and then stuff, and let's go ahead and put a space for easier readability, I could say print example string dot split and then comma. Now, what this is actually going to do, of course, I can't remember if Python is smart enough to understand that there's a space here. I think what it's going to print, if we look at this, it's going to print words, but then it's going to print a space and then stuff in the second item in the list. Of course, this is going to return a list. So yeah, it did print the space. So if you want to include, maybe you always know that there's always a space between your commas, you could just put a space after the comma, and now it'll print properly. So now it'll print the list with the space included in that split. So basically what you're doing in this line of code is, the way the split function works is, well, it's actually a method. It's a string method specifically. In the same way that this right here, stuff dot doing stuff, is a method, this is a method of strings just in general. So the way the split method works is, you're saying every time you get to this specific section of text, I want you to basically remove it from the string. So it's kind of like saying this. And then I want you to create a list of these two items. Of course, it's hard to see because I don't have them spaced out now. But I want you to create a list. And that's what it's doing. So pretty simple, pretty straightforward, very helpful to know. And then let's say I want to not do that. Let's say that we define this as a variable. So let's say split string is equal to that, and then let's get rid of that extra parentheses, and then let's print the split string, which does the same thing. But now let's say print, and then we're going to put a comma here, and we're going to say comma and space, and we're going to say dot join, and then I think this will work. And then we pass in our split string, which takes a list variable, and I think it should print out the original string, which it does. So join is the exact opposite of split. It takes whatever basically it's going to go through here. Excuse me. It's going to go through here, and it's going to look for where each item in the list ends. So, okay, this is the end of the first item in the list. This is the beginning of the second item. So everywhere it finds a space, like everywhere it finds another item in the list, it's gonna it's gonna put a comma and a space, and it's gonna create a new string. And that's the point of doing this part, is we're joining it together as a new string. So that's the whole point of the join method. So yeah. Know that string literals are always enclosed in quotes, with the exception of user input. Yeah, that's right. Basically, what that means is if I say print words, then every time I have to pass a string literally into Python somewhere, for example, I'm passing the word string into the print function. Everywhere I have to pass that function in, I have to enclose it in quotes. I can't just say words, because Python won't know what the heck I'm talking about. I gotta put words here. But on the other hand, if I do input, if I can freaking type, input, please give me your favorite color. Then what's going to happen is I'm going to run this code. And notice everything else is like I'm passing a string literal, but with the input function, it's kind of different in that way. So anyway, because everything I enter into the input function will be, I'll just say green, for example. If I type in green, what's going to happen is, let's just go ahead and put some breakpoints here so I can show you. It's actually going to create a string literal based on what I put in the input function. So I'm going to say green again, and now watch this. I'm going to go ahead and execute. So if we look at our, we didn't assign that to a variable. Whoops. Example input. These are terrible variable names, by the way, but, I just wanted to show you this for the sake of time. Okay. So if I say, like, blue this time. By the way, I saw some study once that said that the entire world's favorite color is blue. Apparently, it's like 70% of the world or something. It's really crazy. I wonder why that is. Anyway, so now you can see that the example input represents a string of blue. Even if I type in a number here, which I could do, I could type in a number. Oh, let me debug this. Let me not run it. There we go. So I could type in a number here. It's still going to be a string though. See? So I'd have to convert that to a string, or sorry, I have to convert that to an integer or whatever based on whatever the person puts in. But yeah. Okay. So with that all out of the way, let's go ahead and move on here for the sake of time. So we talked about input, replace count, upper lower methods. So this is just saying, I could just say, where I print words here, I could just say dot lower, and that's going to print me words without any uppercase in it. Of course, it's already in lowercase, so that doesn't really help much. But if I print it in uppercase, it's going to do the opposite. It's going to print it all with the uppercase, like this. That's where it printed right there. There's also the dot title case, which does the first letter as uppercase and the rest of it as lowercase, which is very helpful to know, especially if you're iterating through a list of names or something, and you want to print it out all fancy and everything. That's a good way to use that. Anyway, okay. The count function, though, will actually return an integer, similar to how the length function does. But let's say I want to get how many W's are in this string. In this case, let's say words space while. So there should print 2. So now if I go do this, it should print 2 right here, which it does. And that's what the count function does. Really straightforward. Now let's say I'm just a crazy person and I absolutely hate the letter W. And let's say I have like a word like where. Okay. Whoops. Can I freaking type today, please? Jesus. Okay. Now let's say that I hate the letter W. For the life of me, it is the worst letter in the world. And I want to replace everywhere I see W. So let's go ahead and say everywhere I see W, I want to replace it with a T. Because W suck. Okay, so now if I print this, it should print out there. And that's how you use the replace function. You say what you're replacing and what you're replacing it with. You can also add another argument here to say how many of them you want to replace. So, for example, I could say where and when. And now if I do this, it should print there and then. But if I add a 1 here, then it should only do the first one. Yeah, see? That's how that works. Pretty straightforward. Excuse me, guys. Sorry. Okay, moving on for the sake of time. So replace, okay, print, understand how the print function works. You can put as many arguments in the print function as you want. I think there actually is a literal limit, but I think it's like in the thousands. It's like really freaking high. If you're ever printing that many things and not using like a list or something, you should probably ask yourself why you're doing that. But you could say this is, wait, actually, I'll say these are strings. I'm telling you guys, COVID is getting the better of me. I can't freaking type for the life of me. But yeah, I can put in multiple arguments in print. Input, however, is a little interesting. In input, I can't say these are strings because well, I definitely can't type that for sure. But yeah, these are strings. Notice PyCharm is smart enough to know that I'm an idiot here because it's telling me, hey, there's like this is an unexpected argument because input only takes one argument right here. So, you know. So input only takes one argument, but print can take multiple pretty much. Okay, moving on. So what was I doing? Print. Okay, understand the max, sum, and round functions. So if I have a list, example list is equal to 1 and 2 and 3. So if I print this, it's going to print me the list of 1, 2, and 3. But if I print with the sum function, so I could say example list, and then I want to put the sum function around it, then it's going to print me 6, which is going to be pretty cool. You can ignore these breakpoints, by the way. I just forgot to remove them. Anyway, so now it's going to print me 6 here, right? That's what the sum function does. Pretty straightforward. It just adds up whatever's in your list. Now, you might run into problems if you have strings and other things in your list, if it's not all integers or floats. So there is that to know. Anyway, and then there's the max function. So you could say max, and that's going to give me the highest value in the list. In this case, it should print out 3, as you can see there. And then what you can do is you can do the round function. Now, round is more of an integer thing, so it's actually more of a float thing, technically. So you could say example float is equal to 3.768, whatever. And I could say print example float, and then I want to pass in the round function, or pass that into the round function, I mean. And then I'm going to say round to 1 decimal. And then what it's going to do is it's going to round that, and I think it should be 3.7, which it is. So there you go. That's what the round function does. Pretty straightforward. Okay, moving on here. So understand the comparison of strings using logical operators, including when characters are numerals. I think that's what this means, like using conditional statements, like is it a digit or not a digit or whatever, and comparing like that. You can compare strings, like for example, I have words and stuff here, so I could say like for word and example string. Well, this is a string. I want like a list. Example list of strings. And then I could say hi and hello. Sorry. So then I could just say like if like for word and example list of strings, then I could say if word is greater than, of course I'd probably want to actually use the index, so I'd probably want to traverse by index. But you could say like if word is greater than the previous word, for example, if you're traversing by index or something, then I want to like make a string that's equal to that. So I could say like, you know, if word is greater than previous word, in which case Python will yell at me because this isn't defined, but, you know, bear with me here. Just pretend that that is defined. Then you could say like, new string is equal to, new string is equal to word, right? And then you could like, if this was its own function, you could return the new string, right? And so basically what this would do is, like what this is saying is it's gonna look through every word in this list, and whatever the like word would be at the bottom of the alphabetical list, it's gonna eventually, when it gets to the end of the list of all the words, like when it gets to all the end of the list, it's gonna finally return what the least sorted alphabetical word would be. So like if this was a list of a bunch of words that all went from A to Z, it would print the Z word with whatever the last Z word is alphabetically. So that's what this does. That's what they mean by comparing strings with operators and stuff. So you can do this kind of thing. Also, you could say if it's equal to, greater than or equal to, or you could say if it's not equal to or whatever. But anyway, that's what that does. Of course, I didn't actually traverse by an index or anything or set this up as a function, so it's not going to work if I try to run this code, but you get what I'm trying to say. So, same thing goes for the 1, 2, and 3. It basically functions the same, but it's just a different type of variable. Okay. So, let's move on here. So, know the list method sort. So, sort is a list method. So, here's the fun thing about sort, though. If I print example list.sort, it's actually going to return none. It's going to print none right here. So if I print this, it's actually going to print none. You can see that right there. And so why, like, what is it doing? Well, here's the thing. If I now print the example list, of course, these are actually already sorted technically, so let me just switch this around here so it makes a little more sense. So now, oh, I had another comma in there. Whoops. So now, if I print this out, now it'll print it the normal way. So what sort does is it doesn't actually return the original list when you evaluate this statement, but it did actually change the original variable. So if I print the example list before and after this statement here, it's going to say none in between because I still have this print statement, but hear me out. So it's going to say 2, 1, 3, and then none, and then 1, 2, 3. And you can see that right there. Okay, so that's what sort does. And the sorted function is kind of the same, except the sorted function actually does something a little bit different. What the sorted function does is it does sort the list, but you have to pass the list into the sorted function, and then you have to print what that variable is or save that variable somewhere. And this could be bad if you don't want to have two lists that are gigantic lists in your blocks of memory, because the sort function might be, like the sort method, might be better than the sorted function, because in the sort method, of course, it's only a list method, and you can use sorted on other things. In my opinion, if you're going to sort a list, you should just use the dot sort. But if you are going to specifically just, like, if you want to get the value of what the sorted value is, you can use the sorted. But anyway, so what this will do is what this output is going to look like is it's going to say 2, 1, 3, 1, 2, 3, and then 2, 1, 3 again. So it doesn't actually modify the original list, if you notice. It just it gives me a new list variable. And then I could do things with this. I could ignore the print statement. I could assign this to a variable, and I could say sorted list is equal to, and then I could just get rid of this parentheses here. And then I could do stuff with the sorted list. I could say for item in sorted list, or whatever. But again, I think if you're going to go through all that trouble, it's not really that hard to just put like list.sort and then do all your code, right at the top of your code, and then do the rest of your code below the dot sort. But anyway, so that's what that does. The sorted function you can also use on strings as well, and dictionaries. I don't think you can use it on integers or floats or booleans, I think, but you can use it on dictionaries, lists, and strings. So that's what the benefit of the sorted function is. The dot sort, where you type dot sort in the parentheses, that is a list method, which is a function that is tied to a particular class, in this case, the class of lists. So that's why that's a thing. So anyway, yeah, that's what the difference is and all that. So it's gonna, if you do the dot sort, it's gonna return none. And remember that print will print whatever the value is. So again, remember that before I made this change, when I printed the list.sort, it printed none, because it's going to print whatever the value of whatever the method returns. That method doesn't return anything when you do .sort, so it's going to print none there. That's why it printed none and not the actual list. But notice when we printed the list after that, it did actually print the modified list. So that's what, because remember, like I've said before, when you print something, it's going to print the value of whatever it equals. So yeah. Okay, so let's move on here for the sake of time. We're actually almost done, which is really good. So I'm going to try to make this under an hour and 45 minutes. Hopefully it won't be too much longer. Understanding lists, indexing, and slicing. So let's get rid of all this crap. Yeah, let's even get rid of our, well, we won't get rid of that, I guess, but let's go ahead and get rid of all this crap. So let's say example string is equal to word, right? So if we print this out, if we print example string and then we print our like 5, this isn't actually going to print anything. It's going to say list index out of range. So let's just use a bigger string so I can show you, because I want to use the same exact examples that they did. So the example string here is testing. If we print 5, that's actually going to print the 6th item in the list, because remember it starts at 0. So this is 0, 1, 2, 3, 4, 5. So it should print the n, I think, if I'm not completely lost my mind. There we go. Now, if we do the 5 with a colon, however, it will print something else. It's going to print the ng, because basically what it's doing is it's saying print everything from 5 onward. That's what the colon does. Now, with the, if we do, we can also do it in a reverse way. We could say print everything up until the 5, and that will give us everything before you reach the n, which is kind of like the range function in that way. But yeah. And then, if you do the -1, if you do negative indexing, for example, I can also, because I know that this list has all these things in there, I could do -2 to demonstrate the same exact thing, and it'll also print me in, if my math is right. Yeah, because what it's going to do is, so G is -1, N is -2, and then I is -3, and so on and so forth. So unlike where arrays start at 0, this starts at 0, so T is actually 0. But if you're trying to do a negative index, you have to actually, like, this will actually start at 1. So it's a little bit confusing in that way. So, yeah, that's just one thing you can do to get, like, negative index. So, also know that the same exact thing applies to lists. So the way I just index and slice the list is the exact, or the string is exactly the same way you do with the list too. So there's that. Okay. Let's see. String concatenation. So with string concatenation, basically you're just adding things to a string. So I could say, for example, I could say print example string plus testing strings, right? And that's what concatenation is called. So now it's going to print the example string plus strings. So you can add things to a string by doing concatenation, which is just plus and then that. Concatenation is just a fancy way of saying add that onto like whatever is at the end of it. So it's like kind of like the join function. You're kind of just like mushing things together. So that's kind of what it's doing. Excuse me. Sorry, guys. Okay. Also know that you can't concatenate like numbers as well, unless Python fixed that and is now smart enough to know how to do that. But I think it will give me an error. Yeah. So you can't concatenate numbers onto strings. So like, let's say for example, this is 1. Whoops. Let's say for example, this is 1. It's not going to print me 3 here. In fact, it's going to give me an error, right? But you could say like int 1, and then that would fix your problem, and then it would print 3. Because then you're converting 1 to an integer, and then boom, there you go. But yeah, you can't just add a string outright. And this is where debugging is really helpful, like I was saying before, because then you would know that your 1 or that your example string is a 1 as a string and not a 1 as an integer. And I know this is obvious because you can literally see what it equals right here, but maybe you don't know what this value equals at that point in time. So this is where debugging is super helpful. Anyway, okay. So, almost done. So string concatenation. Oh yeah, multiplication. Same exact thing. It just takes whatever string you have and copies and pastes it like however that many times. So I could say string times 2, and I can put a space in there, and then what will happen is it will basically just say testing, testing. And that's what, and because I put a space, it doesn't just mush them together, because if I didn't put a space, it would just say testing, testing without any spaces. Because that's basically all it's doing, is it's just taking whatever this value is and just like copying and pasting it like 15 times. So it's basically just saying, like, it's basically just doing this to whatever you multiply it by. That's really all it's doing. Pretty straightforward, right? Okay. So almost done here. So understand conditional execution of codes, if, elif, and else. We already talked about that. Okay. Be able to determine the result of code fragments containing such statements. Yep. We know how to read if statements. Be able to write code containing such statements. Yep. We know how to write if statements. As part of this, you will need to understand Python indentation. So note that every time you put an if, you have to put something underneath it indented by that level. And note that each if has to be indented. Like you can't say if and then put like else to be indented more. Like you can see the red here, Python is confused. You have to put it on the same indent as your if. You can also add another if. Like if this, then also like if this condition is met, then now do this condition. So if next condition, then print next stuff or whatever. But if you add you can't add an elif here because this is the only if in that indentation. So now it's even more confused at me because not only did I not define what next condition is, but I never put an original if here because just because there's an if here doesn't mean I can put an elif here. I have to always have at least one if in whatever indentation that I'm in before I can put an elif. So I could actually say elif other condition, then print other, right? That's fine. But they have to be in the same, like this, they're kind of all contained in their own indentation here. So yeah. Okay. All right. Moving on for the sake of time. So, let's see. Know that else catches all the remaining cases. So in this case, if I put like an exclamation point in my word here, like I was doing, like if this is an exclamation point, it's gonna say it's not a digit, which is technically accurate. That's fine, but it's gonna say, okay, is it a digit? No. Then okay, is it a dot? Then no. Okay, then it's gonna print this. It doesn't care that it's an exclamation point or whatever. It's still gonna go to this if it's not either a dot or a digit. So yeah. Okay. So moving on here. So be able to translate instructions given in English into Python. Basically just saying know how to write code, and we kind of know that mostly when we're not sick and dying, I guess. Be able to define functions given specifications about their functionality and parameters. As part of this, you'll need to understand Python indentation. It's basically saying know how to read a function, and we kind of already talked about that. Understand and be able to write for loops. Yep, we know how to write for loops. Understand what happens if you modify the loop control variable in the body of a for loop. So if you say, let's try that. Let's go ahead and do that. So let's say for I in range 3, print I, and then I plus equals 2. So now, if we go ahead and do that, then now if we execute this code, let's see what it prints out. So it prints 0, 1, 2, but note that it's not going to change the I. Because you see, Python doesn't actually care what you do about I when you're doing something in a range. Because, like, Python just doesn't care that you're modifying I. Because Python is just saying, okay, I'm going to do this 3 times of whatever block of code you put in here. And I'm not even going to care if you modify the I variable. So you don't have to put I plus equals 1 at the end of your list if you do it like this, or the end of your loops. You could, because Python is already going to keep track of that for you. But a while loop, on the other hand, will actually matter if you change the control variable inside of it. So if you do that with a while loop, I'm pretty sure it does actually change the output. But it doesn't matter for for loops anyway. Okay. Know how to traverse lists by both index and element. Yep. That's just the for character and string kind of thing, or for I and range length string kind of thing, but with lists basically. Understand and be able to write while loops. Yep, pretty straightforward. Sorry. You can either write while loops like while true, which just means that it's just going to keep going forever until you do something. So it's just going to say print like 5 here. And then you could say break to stop it, and that will stop the loop. So you could do that. Or you could say while I is less than 1, or you could say I is equal to 5, and then the same exact thing would be like saying I is equal to 5, and then while I is less than 6, then I want to print, in this case, I, because it's already equal to 5. Of course, I was printing a string, and now I'm printing an integer, but it's the same thing, really, at this point. And then I could say, to make this loop actually stop, I could then say I plus equals 1, right? And I don't have to put the break here, because that's actually what it's going to do. I could still use the break, because it's going to do the same thing as this I plus equals 1, but it'll still do the same exact thing as what I just did a second ago, where I just said while true, then print 5. Whoops. So, oh, and I have to break because otherwise it'll go forever. So now, here we go. Does the same exact thing. Now, what break does is it stops the loop. So it's going to stop the loop as soon as it meets that break. And this could be helpful if you have a specific thing. Like, let's say you're taking user input and you say, do you want to roll again? Like in the pig dice game, you could say if the user presses Y, then I want to break the loop, or if they press in, I want to break the loop. Well, actually, if they press Y, you want to keep rolling. So if you want to start the loop over, you would say continue, and that'll start the loop at the beginning, if I can spell properly. And that will actually start the loop all the way up to the first line below the while true. So I'll show you what that looks like. So if we say user input, actually, let's just make this a better variable name. Let's say roll again is equal to input. Do you want to roll again, right? And then let's say y/n. And we'll just leave it at that just for the sake of simplicity there. So now, if I say if roll again is equal to y, then I want to continue. God, I cannot spell today. Else, if it's not equal to y, but if it is, that's what the elif is for. If it is equal to n, notice I put it equals because we're saying does it equal that. If it does equal that, then we're going to say break. And if, like else, if they say, if it's not y or n, then let's continue. And let's just say whatever. Now, in this case, this code kind of sucks because it's still going to ask them to roll again regardless. It's just never going to stop. But I guess that's fine for our purposes. So we can say y like a million times here. But then if we finally say, like, well, we can also say another letter and it'll do the same thing, like I was saying. But if we say in, it just breaks it. And then it does all the other code below this, which was like all this stuff, right? So that's what I mean by like how a while loop works. And this is what I was saying, like, this is why it's good to know when to use a while loop, because a while loop is good when like you're waiting on a condition like that. In which case that wasn't the best code, but you see what I'm trying to say there. Like, it's good to know, like if you're waiting for user input, and you're like, I need to keep repeating this line of code forever until they finally say, okay, I'm ready, or yes, or no, or whatever. That's when a while loop is good. You also see while loops a lot in like game development and stuff because you want the code to constantly loop and update values and update the UI and stuff like that. You see it a lot in UI and game development and stuff because you want the code to just kind of execute the whole script and keep looping on through until they exit the game or exit the UI window or whatever it is that they're doing. But yeah. So, anyway. Okay. So, almost done. We only have like 4 more points here. So, know how to build strings and lists and dictionaries. So, this is pretty straightforward. Just know that to add something to a dictionary, you would say dictionary, and this would represent an actual dictionary variable. So I could say, for example, I could just say dictionary is equal to this, and then I could say dictionary dot stuff, not dot, sorry, dictionary stuff is equal to 1, right? If you remember my other dictionary I showed, this is basically the same exact thing. And you could do this in a while loop, so you could say, like, or like a for loop or something. Every time you find something, you could just create a key and then a value. Right here, you're saying, okay, I want to take that dictionary I made, whatever, empty or not or whatever, and I want to add a new key to it. That's what the stuff is. It's a key. And then this is what my value of that key is going to equal. So that's what you're doing. And you could do that in a while loop or a for loop or whatever. For the sake of time, I won't go all the way into it, but that's basically how you would do it. Let's see. Know how to build strings, lists, and dictionaries. Yep, we already talked about all that stuff. Oh, you can append to a loop, or append to a list, I mean. So I had that list earlier, but we'll make it again, I think, because I don't know where it is now. I might have deleted it. But we could say example list is equal to 1 and 2, right? And what I could do is I could say print example list dot append, and I could add 3 to it. And what that's going to do, what the append method is going to do, is it's going to print example list 1, 2, 3, right? So, oh, I think I did something wrong here. Print. Oh, sorry, because the append doesn't actually return anything, so it's going to print none. That's my bad. Sorry, guys, it's been a day. Okay, so now if I print example list, it should give me 1, 2, 3. So there you go. That's how you add something to the end of the list. Now, note that, as we just now saw from my silliness, that append, this block of code evaluates to none, even though it actually did do stuff. Kind of like the sort. So just know that, I guess. Okay. You could also, and this is one of the later points, actually, this is the point that we're on, pretty much. So, okay, what is the important list method that you need to know to add an item to the end of the list? Yep, that's what we just did. That's append. And then how about the beginning of the list? If you want to add something to the beginning of the list, I would probably recommend using the insert function, but let's look this up here. So Python list methods. Actually, let me show you. This is a good point to show you guys something, which you might not use this for the final exam, but you might use this later on in coding, especially in Python at least. So watch what happens. I can do this. I could say help, like print. Actually, I don't even have to type print because I think it prints it automatically. Help list, right? And so what this is going to do, it's actually going to print every single method that lists have. It's going to be a really long print here. But we can actually look and see what it does. So now let's look for insert here, because I think that's what I was going to look up. Insert object before index. Okay. So it says insert the object before the index, and we have to pass in the index and the object. So both its index and the value. So let's say, for example, we have our example list of 1, 2, 3, which I had a second ago. Where is it? Oh, it's way up there. Okay. So let's say now I want to add a 0 to that list. So here's what we're going to do. We're going to say example list dot insert, and the documents say that we have to type in an index. We can ignore the self because it's a class, so we can ignore the self argument. We have to type in the index that we want to insert it into. So in this case, it's 0, so it's going to insert before. We could put 1 here and do the same thing, but we'll go ahead and do that. And then we're going to pass in a 0 as a string. Now, don't be confused by this. This is the actual index in the list, the integer index. And this is the item that we're adding into the list. Maybe this wasn't the best example, but yeah. Now, if we go ahead and print our example list here, which should print at the way very bottom of all this crap, you should see now it says 0, 1, 2, 3, right? Okay, now we're almost done. So let's see. How about the beginning? Yep, that's what we just did. How do you get rid of the last item? Excuse me. So you could say example list dot pop, I think is what we want. And then we could say -1. And just like we were slicing and indexing the list before, pop should remove whatever item is at this index. So I think if we print this now, if my math is right, we should be able to get the 3 out of it. So it should just print 1 and 2. Yeah. So pop works. You can use pop for that. I think it's the easiest. And actually, pop is actually a really fast function to use. It's one of the fastest methods in Python, actually, for lists. So highly recommend pop. Also, one cool thing about pop, which might be a little confusing, but one cool thing about pop is pop not only removes the item from the list, it actually allows you to use it as a variable. You could say, like, removed item is equal to, and then what you could do is you could say print removed item, because pop actually returns this block of code right here, returns whatever the value at this index is, and then it removes it. Well, it's kind of the opposite order, really, in how it's executing it, but yeah. So now if I print that, it should print out the 3. So not only did we remove the item, we actually got what it was. This would be a really good idea if you're trying to iterate through a list and like maybe you want to remove something or you want to grab a specific value and you want to remove it as you go. I don't know what your use cases are specifically, but that would be a good example of when to do that. So that's how you do that. Okay, so let's see. Element at position I. So I guess it's saying like if you're iterating through a list or something. So you could say, I think the easiest way to do that is just using the pop method. So position I just represents whatever your index is. So like I said, we wanted to remove the last item from the list. But you could also just do like, let's say I want to remove the first item from the list. In this case, actually, it's not 1. I mean, the first is in the array. So like 0 and then 1. So technically, I'd be removing the 2. So I could just use the pop method again. I could say example list dot pop and then 1, which will actually remove the second item in the list. Kind of confusing, but you know. So now if I print the example list, it should just print 1 and 3. There we go. That's like what they mean by position I just means the index, and see this here, the 1 that we passed into the pop method is the index that we want to remove, so that's your I in that case. If you're doing like for I in range length and traversing by index or enumerate or something, that would be an example where you could just pass I in here if we had some kind of like for loop going on or something, or a while loop or something, but in this case we don't have a while loop, so we're just removing it directly without the loop, but yeah. Okay, almost done. So knowing how to create and modify lists and dictionaries. Yeah, I already kind of went over that. I've shown you how to create a list right here, and I've created dictionaries today, so we won't really go over that too much. Understand that lists are indexed by integers. Yep, so that means I can access the list by the integer, or by the index right here. So, for example, right here, I popped the first item, which technically is the second item, out of the list. So, that's the index. But if this was a dictionary, I couldn't just do that. First of all, pop isn't even a method of dictionaries. But second of all, even if it was, I couldn't just do that because it doesn't take, like, dictionaries don't have indexes. You can't say like for I in range length dictionary or whatever. You would have to access the index explicitly by saying like for index in whatever, or not really index, but you'd have to access like the keys themselves. I mean, sorry. So, the index, quote unquote, of the dictionary are keys. So it doesn't really have like a typical index like a list would. But you still should know how to remove items from the dictionary given that key. So you could say, like, actually, let's show you again. So let's go back here and let's say help dict. And that's the thing for Python's word for dictionary objects, the classes. So let's say help and let's figure out what we can do to dictionaries. This is a good example. So let's see, we have an update method, we have a values method, that's where you get the values like I showed you before. We have a set default, a pop item, so you can remove and return a key and a value pair. So there is actually does have a pop method. Okay, cool. So it removes the specified key and returns the value. So yeah, it does have a pop method. I apologize for my misinformation there. But it's not removing it by index, you're removing it by the key. So it's not technically the same, but you could do dictionary.pop if you wanted to. It just would print that way. Keys, items, we already went over that. Get is how you see if a key is even in the dictionary at all. That way you don't get an error when you try to access that key if it's not in there. So then it will say like true or false or whatever, and it'll just get that key. Copy is how you make a copy of the dictionary, which we know. And then clear removes all items from the dictionary. So I guess what you would want to do is you'd probably just want to use the pop method here to remove the item, I would imagine, because I don't see any other methods here to remove any items from the dictionary. These are all the like class object stuff here. These are actual methods that we can use. So yeah, I think that's about it. I think we would want to, I think that's all we can really do here. So yeah, okay. So I guess just pop and pop item, I suppose. And the difference between those two is that pop you have to pass in the key and then whatever the value is, but it removes a specified key and returns their corresponding value. Well, it doesn't actually remove that, but you just pop it in that. It gives you the value back. You don't have to pass the value into it. If the key is not found, their default is returned if given. Otherwise, a key error is raised. Okay. And this is saying it removes and returns a key value pair. So the difference between these two is that one will just return the string. So if you were to print like dictionary.pop or whatever, it would only return the value. It would only print what the value of that dictionary item was. Not the key, but the value. Whereas pop item will return a tuple that contains both the key and the value, and it will remove it as well. So it's close, but it's not exactly the same. So you can see the difference there. Okay, anyway. All right. Know how to traverse a dictionary by key using a for loop. Yep, we already kind of talked about that. That was just for key in dictionary.keys. I have it right up here, actually. Let's see. Know how to do it with the keys in sorted order. We already talked about that. You just put sorted before it. Or you just do .sort, but you wouldn't want to do .sort here. You would just want to do dictionary.keys.sort and then do for key in dictionary.keys or whatever. But yeah. And then know how to do it with the keys in the sorted order. Oh yeah, we just read that. Okay. Know how to open and read and traverse by line and write to and close a text file. We already talked about that. So you just say, oh, like, you just put the open function in there. And then you put the open function in there. So you have like a text file right here. Let's say the text file name is my text file.text. Then you just say open. And then you can just say file object is equal to open. You use the open function. And you pass in the file name. And then you pass in whether you want to read it or write from it, or read from it or write to it or append it or whatever. And then you just say for line in file object. So this will print each line of that text file. I want you to print the line, right? And that's the easiest for loop I can give you for text files. As far as writing to one goes, well, then you have to either like write, like you have to use like the file.write function or something, but you could also just use this to read from it, and then you could say line.write, or in this case, file object.write, and then you could pass in your line here, and that will write the file with the line. Of course, you wouldn't want to write the file that you're currently iterating through. Ideally, you would have a second file. You would have like second file name is equal to file to write to dot text, just so it's clear what we're doing here. And then second file object is equal to open file, second file name, W, right? Or append, whichever one you want to use. I would do W because then it overwrites the file in case you have some weird error where you have to run the code again. If you were to run this code again, it would work the first time through. But if you were to do it the second time, it would just double the file, basically. It wouldn't be what you want. So I would recommend just opening it with W. So now this will basically create a copy of the first file. And then you could just, I know this isn't in a function, so it looks kind of weird. But you could just say file object.close and then second file object.close, right? And that would be the simplest and easiest way to write to another file given the information from one file. I think that goes over everything as far as that goes. And then also, if you want to iterate through by character of the line, like let's say just writing the line isn't good enough. Maybe you want to look at each character to see like if it's a digit or not, for example. Then you could say for character in line, if character is digit, then print character is a digit, right? Simple as that. And that's now what you're going to do is when you go through this file and it goes through each line, it's going to also not only go line by line, but it's going to go character by character in each part of that line. So that's how you do that. And CSV files are exactly the same syntax, except in this case, the only difference really is that there will be commas separating each different value. So you have to like split the line by comma and stuff. So you might want to do, which I'll just, excuse me, I'll just do this. I'll just do split line by comma is equal to, and then we'll say line dot split and pass in our comma in there. And now it will give me a list. This will be a list, by the way. So now you could say, like, let's say you want to like, let's say you want to create a new like line that doesn't have any commas in there, but it's separated by spaces, for example. Then you could say empty string with a space dot join split line by comma, and you could just say joined line with spaces, and then you could say write joined line with spaces. So now this will be a string. So this is a string right here. This line is a string. This is a list of what this is. It's a list of all the items in that string separated by their commas. This, which this has to be a CSV, but you know what I mean. This is actually a string now. It's taking everything that was split up and just adding a space. So now what it would look like is you would have, like, for example, if your line, example line here, was equal to like stuff 2, stuff 3, then what it would actually write to the file is it would look like this. It would say stuff 1, stuff. Oh, I did stuff 2 there. Whoops. That's what it would look like. That's what this line of code is doing. So this separates it into a list. So then the example line split up would look like this. Stuff 2. Almost made that mistake twice. Stuff 3. So this is what this line of code looks like. It looks like this. This is your original line. This is the split line that we did here. And then this is the joined line. And this is also what it's writing to the file. That's what this write function does, or the write method. So, yeah, that's basically it. Okay, well, that kind of covers everything in the study guide. I do want to go over debugging one last time for the final time, and then I'll stop talking about it forever. But debugging is super important, and I'll show you this in VS Code here. So this is VS Code. Same kind of thing, just VS Code, not PyCharm. And so what we can do is we can go ahead and add some breakpoints real quick. So our string is word 1, 2, 3, so we don't have to put a breakpoint there. We can put a breakpoint in our function there. So these are our breakpoints. You can't really see the line specifically, but you can see the breakpoints. So I added the breakpoints. I just click there on the little points. And you want to put your points. You can put your points in the entire file if you want, but I'm putting them here so that you can see, because this is where it's going to stop at. If I don't put a breakpoint here, it's just going to like keep going, and it's not going to stop here. So yeah. Okay. So now the second step, that's the first step. Easy as pie, right? Just 1, 2, 3, 4, 5, done. Like just literally click and boom, you added it. Like how easy is that? Now you just got to go here and click to debug your Python file instead of run the Python file. And you're going to notice a little window here when we start going through it. So there's a little window right up here that shows your string variable. So this is our string. Now we can see what this is, but let's say this was like hidden from us, like buried way deep in the code, and we don't know what this is referencing without like control Fing and looking for it. So, but it's very helpful to know what it is to begin with. So now we can click this little icon right here. It says continue, or just press the key combination right there, or the key shortcut. So we go ahead and do that. Now it initializes the first character after it's run. Oh, sorry, guys. Okay, so now it's on the first if statement. So is W a digit? Let's check that out. Is it a digit? Let's go ahead and execute that line. Nope. Okay, it's not. So we're going to go ahead and go to the else. And yep, it's an else, so it's not that condition. So we're going to go ahead and print. And we haven't actually printed anything yet because it's not executed this line. It's just stopping here. So let's go ahead and execute that line. So now it just printed W is a digit. Now if you look at that, it still says the character is W because it hasn't executed this next line of code yet. So now when it goes back through here, it changed that to an O. So now we're on the second digit. So is it a digit? No. Okay. And then, you know, it's just going to print not a digit, right? It's going to keep going through that. And each time it's going to get to the 1. When it gets to the 1, then it's going to say, is it a digit? And it's going to say yes. So now it's going to print is a digit, right? And it's just going to keep going through. And that's just how it works. And it's really important to know not only what the value of your variable is. In this case, like it was a W when we started out with, like right here. So now we can see what our code is doing line by line and what decisions it's making. So if you have a code that has like a bunch of if statements and you're like, why is that not executing? Well, there you go. You can just like look at it and say, okay, is it a digit? Like, why is this not executing? W is a digit, you know? It's like, oh, well, apparently it's not, you know, because W isn't a digit. But, you know, you could be mega confused that day. I don't know. Like I am all the time. So, you know, you could just say, okay, why is this not executing? And then there you go. So not only do you know what the value of your variable is, It also tells you what type your variable is by these little like points here. So you can see it has the quotes there, which means that it's a string, so that now we know that it's a string, right? Makes sense. It's a string. So now if we skip ahead though, notice the 1, when it gets to the 1, it's still going to be in a string because it's, it's the whole thing is a string. But is it a digit? We're going to pass that into the string function, and if it is, then we're going to print, is a digit, and then there you go. Right? So pretty straightforward, right? But this tells us not only what the value of our current variable is, but also what the type is. Because even though, yeah, 1 is a number, it's still technically a string because it's within a bigger string. So it's still technically a string. But anyway, okay, I think that's going to do it. That's how you debug your code. Super, super important to know. And if you have any questions, just feel free to message me. Although I'm sick, so I might not reply too quick or too much this week. But just like comment in the thread any questions you have, and I'll try to go over it or whatever. But anyway, all right, I'll see you guys later. Take care.